Welcome back, my dear students. Here's our chromatogram and what it looks like. If you look closely, the ink has run up the paper with the solvent, in our case water. And if you look, that green ink has divided into three different colors. Blue at the leading edge, yellow at the tailing edge and bringing up the rear, and green in the middle. I don't know if the green in the middle is a mixture of blue and yellow together or is a separate green dye. But what we do know is that this green marker that I used for this experiment is not just green ink. It definitely has at least two and maybe three different colors in it. It has blue, it has yellow, and of course blue and yellow make green, and it may have some green on top of it. If you want to look at some of the other ones we've done, this is a black marker that was done by a student, and it separated into blue, a reddish brown, and a yellow. And I imagine if you mix enough colors together, you'll get black. This was a black marker that we separated out. In several cases, it was clear that the marker was simply a mixture of blue and yellow. In other cases, we had some green in the mixture. I don't know if it's really obvious, and just a tiny bit of blue. And we noticed that the darker greens had more blue in them, of course. So, now that we've seen it and we've proven something about this, we'll set this aside to dry. If we were not virtual, I would have you, dry it and staple it to your lab report, but let's go back and answer our questions. So, you have this PDF. I turned it into a fillable PDF, so you'll notice the text boxes. Put your name and the date down, what section you're in, and read through that experimental protocol. My virtual students can do this at home if you have a green marker. And I know you don't have chromatography paper, but you must have a straw or a pencil you can use and a small clear glass or a plastic cup. One thing you can use that makes very good chromatography paper is coffee filters. Cut a strip out of a coffee filter and use that. So, how did the appearance of the filter paper change during the procedure? Those of you who are doing the experiment here, I'm not sure what you can insert in this text field, but you can take a picture on your phone and that would show me its appearance. How did it appear? Here, look at it yourself. The picture's worth 1,000 words. But clearly, bands of color appear as the alcohol, or as the solvent, in this case we used water, moves up the paper, carrying the ink with it, separating out the pigments as they go. So, let's move on. This is a quick lab. Has 3 quick questions. The next question is, what is the evidence that that green ink in that marker was a mixture of inks? Or is a mixture? And that's what we're studying now, is mixtures. Well, the bands of different color that we got when we performed the chromatography experiment indicate that green ink is a mixture. You know, I'm a chemist. I know there are plenty of good green dyes. Malachite green is one that comes to mind. I'm wondering why didn't they just use a green dye? Maybe it didn't get them the color of green they wanted. I suspect in the world of business that a mixture of a blue and a yellow dye is cheaper, then perhaps the green dyes are more expensive dyes. I don't know. But I know, cost drives many decisions. So, what evidence is that green ink is a mixture? The bands of different colors on the chromatogram indicate that the green ink is a mixture. And finally it says, how would you use this procedure to identify an unknown type of green ink? And this is done professionally when you're analyzing color samples, or it's done in a forensic laboratory when you want to identify what type of ink was used in, say, a holdup, robbery note at a bank robbery, or a kidnapping note. You can take some of that paper, extract the ink from it, and then do chromatography with it and compare it with the different brands of ink available. You can tell what kind of pen and what color ink that person used to write the note. So, how could you use this? The color pattern of an unknown ink can be compared with the color patterns of known inks. The color pattern of an unknown ink, unknown type of green ink, can be compared with the color patterns of known standard samples. Now, when we did this, and we did some of the light green marker, here for example is the Crayola green versus the Crazy Art green. The Crazy Art green had a lot more blue in it than the Crayola. So if I gave you an unknown and said it's one or the other, you could just run a chromatogram and compare it. Fill out your answers. This type of sentence. Please remember to write incomplete sentences and use complete sentences when you write your answers down. Hand your reports in, and I'll see you in the next video. Goodbye now.